Okay, I'd like to take some time to review what all of this means. So, as you know, you completed the the four different power tests, and this all of this data was calculated using INSCYD, the power performance decoder, and it really is going to help us dial in the type of training that's going to be best suited for you. So, what I'd like to do first is you have to kind of hang in there because I'm going to give you an overview of everything here. Some of it will likely be repetitive and stuff that you already know, but I'm going to go over the various the various performance benchmarks that we're looking at, and then at the end I will explain how it's going to relate to the type of training that we're doing. Okay, so the visual above it shows a lot of the very key performance benchmarks. Okay, so if we look at the first one, it shows your maximum aerobic capacity, or your VO2 max. So with every milliliter of oxygen your body is able to take up and use in the metabolism, energy is produced. If we have a higher VO2 max, it means a higher energy turnover, and therefore we're going to be able to produce more power. And pretty much in all sports, it's desirable to have a high VO2 max, okay, because it allows us to have a higher power production and taken care of by aerobic metabolism. Now, if we look at the next one, VLA Max, this is going to well, this depends on the type of sport you're involved in, okay, and whether or not we want high or low. So VLA Max is a maximum lactate production rate. With every amount of lactate that we produce, the muscle also produces energy. So VLA max, it's viewed as a maximum glycolytic power. Okay, so or if we can simplify that, we'll say anaerobic capacity. And for endurance events like an Ironman, half Ironman, a lower VLA max is desirable. Okay, so if we have a low VLA max, it allows for us to use more of a higher percentage of our VO2. Okay, so it also allows us to have higher fat combustion, and we use less carbohydrates the lower our VLA max is. Okay, but if we take the flip side of that, if we have a low VLA max, that also is going to mean that it's going to compromise performance in sprints. So for events like a crit race with lots of sprinting, short intense bouts of intensity, a higher VLA max is going to be better and more desirable. So if it's too low, we're not going to be successful in those events that require short, punchy, hard, intense efforts. Okay, so next we look at anaerobic threshold. The anaerobic threshold is a really important benchmark in endurance sports. It's the intensity or the power at which the production of lactate in the muscles is equal to the amount of lactate that we're clearing. Okay, it's the highest possible intensity that can be sustained without accumulating lactate. It's a tough effort. It's hard. It's challenging, but we're not accumulating lactate. And if we look down below, our next one is fat max. So this is the highest fat oxidation rate. So simplified, it's a maximum amount of energy in kilocalories from fat combustion per hour. If in endurance events like an Ironman, a high fat max is ideal for endurance performance. Okay, carbohydrates are pretty limited, even though we can carry a lot within our the stores in our body. It's best to be able to use a large amount of fat to help with endurance performance. Oh, one other thing that I should mention with fat max, it's also can be looked at as a training intensity, which I'll get to towards the end. But that's a training intensity that's beneficial for endurance events. So carb max, it's the intensity, the power at which the combustion of carbohydrates reaches about 90 grams per hour. So lots of studies indicate that that's pretty much the upper limit of what we can absorb. 90, maybe 100. Doesn't mean that we can't take in more, but that's about the limit of what we can absorb, and even that is tough. It's tough for many people to take in that many carbs. So that's looked at as the maximum. So this rate of carbohydrate use is what we can take in, what your body is demanding per hour. Okay, and so at 90 grams per hour, it gives us for you, it gives us a wattage range 2.5 watts per kilogram. Okay, so let's go ahead and move on to the next graph. And so you're going to see training zones, and if you'll notice, these training zones are different than the traditional training zones based on percentages of like FTP. And this gets us into far more specific types of intervals, types of training that's going to benefit you. So what I'd like to do is just kind of briefly cover a few of these, and then let you know what you're looking at as far as the graphs or the charts here, and then let you know how this is going to impact your training, what we're going to do. So you'll notice here, you're like zone 2, consider that base. At the lower end, that's 150 watts. On the upper end, that's 194 watts. Your target being about 176 watts. Okay, now if you plug in your FTP and you base it on percentages, you'll notice that these targets aren't always going to fit with what is traditionally considered zone 2. When I adjust your training, when I dial in the wattage that I want you to push, I'm going to be doing it with these targets in mind. Okay, so even though I will still use percentage of FTP, I'm going to adjust the percentage so I'm hitting these intensities that I'm reviewing with you. Okay, so the next one is zone 3. And keep in mind, these zones it's not your traditional zone 1, 2, 3, 4, and 5. Okay, but just look at these as their own zones. So the medio zone, it starts at the lower end at 192, and it goes up to 219. 247, with the target being at 219. And so there will be times where I will have you work out and complete intervals at 220 watts as your target, and there's going to be specific purposes and reasons for that. Okay, if I want you spending more time in your fat max, which will help you to develop your body's ability to use fat for fuel, your upper limit becomes 190. Okay, your upper limit becomes 190, and your target is about 170 watts, 173 watts, with the lower end being 155. Now, keep in mind, as your VLA max drops, this upper end range will start to increase, and that's the goal. Our goal right now is to improve this so that come race day, you're optimally using fat and getting as many watts as possible out of that fat max range. Okay, and then anaerobic threshold. Once again, your target, your threshold is 266, but it's always a range, right? It's never precisely that, but on the low end 247, and on the upper end 284. Okay, and so the intervals where I'm going to have you do maximum aerobic work without going into the anaerobic it's about 368 for your target wattage, and these will be limited in duration. They'll be fairly short, and I don't want you to spend too much time above this or at this, because I don't want too much lactate being accumulated. We want to kind of make sure we're limiting the lactate production that is present in your physiology right now. Okay, and high anaerobic and lactate shuttling, those have specific purposes, but for the purpose of Ironman training and getting you as efficient as possible, we're going to be operating within these first 6 zones most of the time. Okay, doesn't mean we won't use these, but it just means most of the time we're going to be in your first 6 zones. Okay, so I want to go back to this here. Okay, and so one of the things that impacts the percentage of your VO2 max that you're able to use is your VLA max. Okay, so if we look at a target, okay, if we look at a target, your anaerobic threshold, or FTP, let's call it, or your your threshold is you're at 266 watts. You're using, let's call it 76% of your VO2 max. I'd like to bring that range up to more in the 80%. Okay, and the only way that that's going to happen is an increase in the VO2 or a reduction in VLA or a combination of the two. Okay, so what I look at is, at 55 for your VO2 and at 0.55 for your VLA max, I ask myself, okay, which dial do we need to turn? Okay, and some of this depends on the time of season we're in. So if we're 5 weeks out from your race, then I'm not going to be at all concerned with your VO2. My whole entire focus is going to be on lowering this. Okay, so with that said, when we have more time, I still want to lower this, but it's not going to be as urgent because you're not racing in the next 5 weeks. Okay, but what we'll see is when this drops, okay, and what do we want to get it to? So typically, I like to see this in the 0.35 range for male athletes. Okay, if we can get this into the 0.35 range, then your anaerobic threshold is going to start to climb rapidly, and we'll be using a larger percentage of our VO2. So just want to emphasize that when you lower your VLA max, we are then able to use a higher percentage of our aerobic engine. Okay, and that's the goal. So if I were to identify limiters right now, if you were, obviously you're not race ready right now, but if you were to go out and race, this would hinder your ability. And so this would be characterized by, most likely, like, the power is going to feel easy, and then it's not. Then it's going to really take a toll on you, because the higher this is, the less fat we're able to use for fuel, and the more carbs we're going to be using for fuel. So lowering this is going to have a ton of benefits for you. But right now, I want to lower this, and I want VO2 to climb a little bit more. If we can get that closer to the 60s by race day, then that would be ideal. Okay, so just wanted to cover some of this information with you as far as what you need to do with your training. Everything I'm going to assign you is going to be based on these training zones. Okay, so in your training peaks workout, you will see ranges of wattages, and those ranges of wattages, I'm always assigning those with these numbers in mind. Okay, now keep in mind, it will adjust, because as you continue to train, as fitness changes, so will these zones, and your targets will change. So just want to let you know, I'll give you a copy of this so you can see the actual zones, and you can take a look at that. Oh, one other thing that I didn't mention is, this also gives you a energy requirement at these various intensities. So for example, let's say you did a 4-hour ride at 170 watts. Okay, that would take you about 670 kilocalories per hour. Okay, so 57% of that would be coming from fat. You don't need to worry about supplementing that, but 43% would be coming from carbohydrates. As far as absolute grams, you're looking at 70 grams of carbohydrates per hour. Now, I wouldn't suggest trying to replace that much, especially in training. So you don't need to replace that, and I want to make it clear that I don't expect you to go out and take in 70 grams of carbs per hour. If you're racing, that would be a different story. But if you're just training, you can do a fraction of this, and I can give you recommendations about what to take in. A lot will be based on kind of what you're already accustomed to, but this lets you know the energy demand of those intensities. One of the other graphs that you'll find beneficial is this right here will show you, as your wattage increases, your 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 body's ability to use fat starts to decrease, okay, and your body's dependence on carbohydrates starts to increase. So, like for example, the crossover point for you is at about 195 watts. So at 195 watts, that shows that you are, requiring about 90 grams of carbs per hour, and you're at about 365 kilocalories of fat per hour. So this chart here will give you some good info, and I can explain this in more detail and go over this with you if you have questions. All right. So hopefully this was helpful. There's a lot to this profile, but just wanted you to know, for me as your coach, I'm going to make sure that I'm aware of everything that we've looked at and really adjust and dial in your training so it takes all of this into consideration. All right.